This is our brand new bench, JobMaster. It's focused around the pneumatics, hydraulics, and PLC system. The unit is completely modular, so it starts off as a base unit. It's just this top half, separate from the bench and tables and monitors. You can add, even to the base unit, you can add the monitor stands. You can have a monitor / full computer connected directly to the bench. If the user wants to upgrade, they can upgrade to the top half and then the lower half bench. Also, part of the bench, there's an optional table tray for students to put projects on or assignments. And then we also have an option where they can hang hydraulic hoses off the side of the bench. This is our accessory cart, and the accessory cart is designed to act as a storage facility for all the options for the pneumatics, hydraulics, and PLC. It's double-sided, and it can hold both pneumatic hoses and banana plug cables or regular wires that would be used in projects. What we have here is power supply, Siemens PLC. It's an S7-1200. We have HMI, a relay panel, and a operator panel. And what we have running here on this bench is I have a roller coaster project, which is designed to be like a final project after students have taken all the accessory projects with pneumatics, basic electronics, and then PLC programming. And it's kind of used so you can encourage the students to go home, do their homework with the e-learning platform, LearnMate, and then move on, come back to school, and then basically give them the option to use the roller coaster. If you tell a student to just play with this system as pneumatics or just PLC or just electronics, they might not be so excited about that. But if you tell them you get to program the roller coaster, they get really excited about that. So it's a big push on project-based learning, and this is one of the projects for pneumatics. In this project, the roller coaster project is basically incorporating sensors and pneumatics into Kinect's like Double Dare roller coaster. And basically, what we did was I added a bunch of limit switches and micro pneumatics to the roller coaster in various places. There's one at the top of a belt that basically the roller coaster comes up to the top of the belt and it triggers the sensor. After the roller coaster comes down from the belt, it stops at this little stop right here, which is also a micro pneumatic, and waits to trigger the next sensor. We have a limit switch here and here to calculate speed of the roller coaster. The roller coaster goes to the loop, and then it triggers that it's reached the end of the course. When it reaches the end of the course, it triggers the next pneumatic, and then it turns back on the belt, and the cycle repeats. So I'm just going to turn it on and let it go. So roller coaster reaches the top, it senses that everything went okay, the coaster goes down and loops, and when the thing reaches the end, it turns back on the belt. It looks like a big fluid option, and if anything goes wrong, the PLC is programmed to safe automatically and stop the belt. So the HMI is currently reporting the number of laps, and you can see one of the coasters didn't make the loop, and it stopped the whole system in a safe way. On this side of the bench, which is double-sided, we have an elevator project. It's the same idea as the other one. We have our power supply, operation module, buttons, inputs, relays, PLC module, and an HMI. And you can see they're in a different configuration. They're really flexible. You can install them in any way you kind of want. And what we have here is an elevator project. And the elevator project basically uses some digital inputs, some additional switches that I made up, and a call panel. So these would represent the 3 floor buttons that you would see outside of your elevator, and this would represent the panel that's inside the elevator. When you push the button, it shows what floor the direction of the elevator and what floor it ends up on. And then also the elevator has multiple sensors on the piston that the PLC reads live. Also, one of the things that we did was, you notice in an elevator normally it kind of does this little whoosh thing at the end when it's leveling, and we actually replicate that here. If you look closely on the sensors, they kind of like blink and then blink back. The other thing we're doing that's unique to this is we're actually controlling the pump for the hydraulics via the PLC. And then underneath here we have the hydraulic pump, and then here we have a shelf that can be removed and replaced with the air compressor for the pneumatic side.